Hello everyone, welcome to another episode from Chedexcel. Today we are going to talk here about how to balance redox reactions. Now the last video on this particular chapter we discussed how we can find the oxidation numbers. So I will put a link and you can get that particular video from this pop-up banner because we need to have a rough idea about the oxidation numbers. So we discussed about the oxidation numbers in that video. So today we are going to talk about how to balance the redox reaction. So this is chapter 3 of unit 2. So we will be talking about group chemistry, redox and the group chemistry chapter. So this is today we are going to talk about how we can balance redox reactions. Now to balance redox reaction there are two main methods we can use. One method is using oxidation numbers, the other method is using the electrons. Now the oxidation number method we mainly use it in unit 5. So I will talk about that part when I put a video on about unit 5, and today I am going to talk you about mainly how we can balance a redox reaction using electrons. Now in this method you have to write the oxidation number, oxidation reaction and the reduction reaction separately, and we are going to balance it. So today we are going to talk you about that method, how we can balance redox reaction using electrons or using oxidation and the reduction reaction, right. So the first thing is there are few basic rules like thingy that we have to remember when balancing redox reaction. So I will give those steps while balancing the reaction, and then I will do another example as well. So let us say we are going to balance this reaction. This is a very common reaction that you found in A level, right. So MnO4 minus manganate 7, or we call them as permanganate ions, reacts with iron 2 plus to give iron 3 plus ions and Mn2 plus. Now we can't just balance the redox reaction by looking at the oxygen and iron, right. So we need a specific way of doing it. So this is the method we are going to use, right. The first thing is first you have to balance elements other than, okay, the first thing you have to write both oxidation and the reduction half reactions separately, which means you have to write this one MnO4 minus goes to Mn2 plus, Fe2 plus goes to Fe3 plus. You have to first note down these two reactions separately, right. So in papers usually they ask write the oxidation half reaction that gives Fe2 plus to Fe3 plus, write the reduction half reaction that gives MnO4 minus to Mn2 plus. They will be given it like this for unit 2 and 3. Unit 5 they won't be given, you have to balance it, but here this is up to unit 2. So you will be given this reaction. The first step is balance the element other than oxygen and hydrogen, right. Now in this case you do not have it because oxygen is already balanced. So in the first step is not applicable for here, right. The second step is balance oxygen by adding water. Here you have 4 oxygen, so you can put 4 water molecules this side. To balance oxygen we put water, that is the first thing. Here you do not have it. Second step or the third step is balance hydrogen by adding H plus. So here 4 into 8, so you have to put 8 H plus, not just H, H plus, 8 H plus. Then the next step is, so here also it does not have. Then we have to find balance the charge by adding electrons. That is the most important thing to find, you have to balance it properly. So this side the overall charge is plus 2, water is neutral, so you do not have a charge there, manganese plus 2. Here MnO4 minus 1 charge and 8 H plus. Now remember this is not just H plus, this is 8 H plus, which means you have plus 8 charge there. Plus 8 minus 1 plus 7, this side plus 2, so there are plus 5 difference, we put electrons to this side. So that top reaction is, we say it is balanced. The bottom part you have to balance just the charge, plus 2 here, plus 3 here, to make them equal you have to put electron, 1 electron. There are no oxygen and no hydrogen to balance, right. So this is actually we call them as reduction half reaction, this is oxidation half reaction. Then what you have to do is you have to multiply both reaction by a suitable integer in order to make them to have the same number of electrons. Now here it's already balanced with 5 electrons, here it is balanced with 1 electron. To make them to have the same number of electrons, I can multiply this by 5. Then it comes like 5 Fe2 plus, that gives you 5 Fe3 plus and 5 electrons. That is it. Now what we have to do is, after you get the same number of electrons, you can add these two reactions, 1 and 2 let's say. When I add 1 and 2, they ask normally, then using your oxidation and the reduction half reaction, get the overall valence reaction. So to get the overall reaction, you have to add 1 and 2. Then what happens? 5 electron plus 8H plus MnO4 minus plus 5Fe2 plus. That gives you Mn2 plus 4H2O plus 5Fe3 plus and 5E. So you can cancel off these electrons. If you have H plus O water, you also have to cancel them as well. The remaining part is the balance redox reaction, which is 8H plus MnO4 minus 5Fe2 plus gives you Mn2 plus 4H2O plus 5Fe3 plus. So this is the balance redox ionic reaction. By looking at the very first reaction we wrote over here, we can't actually imagine that it will have 8H plus 5Fe2 plus, but that is how it is. So that's the step you have to do. Write the oxidation half and the reduction half separately, balance oxygen by adding water, first balance elements other than oxygen and hydrogen, balance oxygen by water, balance hydrogen by adding H plus, balance the charge, make them to have the same number of electrons and add it. That's how we do. So we will do another example, right, that we have to balance elements other than oxygen and hydrogen. So that is one example, right. Okay, so we will do another one and we will see how to do that one as well. So balancing redox reactions commonly comes for unit 2, and that will give like 5 marks out of 80. I'll take this one. Cr2O7 2 minus reacts with sulfur dioxide to give Cr3 plus and SO4 2 minus. That's a reaction. So what is the first step? Write the reaction separately. Cr2O7 2 minus goes to Cr3 plus, SO2 goes to SO4 2 minus. Right. Again, the first step, balance elements other than oxygen and hydrogen. 2 chromium, 1 chromium, so first you have to balance that. Here it is also already balanced, sulfur. Then balance oxygen by adding water. 7 here, so 7H2O. Then balance hydrogen by adding H plus. 7 into 2, 14, so I put 14 here. Then balance the charge. 2 plus 3, that means plus 6 into this side. Minus 2 plus 14, that is plus 12 into this side. So there are 6 electron difference, so 6 electron here. We'll go to the next one. Balance sulfur, that's already balanced. 2 here, 4 here, balance oxygen by adding water. So 2H2O to this side. You have already 2, so only 2H2 is remaining. 2 into 2, 4H plus. Then charge. This side total 0 charge, this side minus 2 plus 4 means plus 2 charge. So you have to add just 2 electrons. Again, 2 electrons, 6 electron, I can multiply this by 3. If I multiply this by 3, I'll get like 6H2O plus 3SO2, 3SO4 2 minus, 12H plus and 6 electron. Then in order to get the balance reactions, I have to add this reaction and this reaction. So I am not going to write electrons because it is already cancelled out, but I write the H plus and show you how those will get cancelled off. So 14H plus, Cr2O7 2 minus, plus 6H2O, 3SO2 gives you 2Cr3 plus 7H2O plus 3SO4 2 minus plus 12H plus. Right. So you can see 14H plus, 12H plus, so the H plus would be cancelled off. We'll have 2 here, 6H2O, 7H2O, so it will be also be cancelled off. Therefore, our redox reaction would be 2H plus Cr2O7 2 minus plus 3SO2, that gives you 2Cr3 plus 1 moles of H2O, 3SO4 2 minus. So this one we wrote on the top. Once it is balanced, it would appear like this, right? So balancing redox reaction is not that hard if you get the pattern how to do this. So this is how you can balance the redox reaction. So I balanced 2, I'll do one more, and third example, right? So when you are doing this, you have to practice many as possible until you get okay with this, right? We'll do another one. Okay, the same as earlier, MnO4 minus plus C2O4 2 minus oxalate gives you Mn2 plus and carbon dioxide. Right, how do you get this one then? First, MnO4 minus goes to Mn2 plus, C2O4 2 minus goes to CO2. First balance manganese, it's already balanced, 4 oxygen, 4 H2O, 4 into 2, 8 hydrogen, so 8H plus, plus 8 minus 1 plus 7 plus 2 that side, so 5 electron to this side. C2O4 CO2, 2 carbon, 1 carbon, so put 2 here. Then 4 oxygen, 2 into 2, 4 oxygen. Oxygen is balanced, so no more water to be added, no more hydrogen to added, minus 2 charge, so I have to put 2 electrons this side. Now you can see 5 electrons and 2 electrons this side. So to make them equal, I have to multiply this by 2 and this by 5. Then I can get the 2 reactions. So this will come like 10 electrons plus 16H plus 2 MnO4 minus 2 Mn2 plus 8 H2O. If I multiply this by 5, this comes 5 C2O4 2 minus gives you 10 CO2 carbon dioxide, 10 electrons. I am going to add these 2 electrons, get cancelled off, 16H plus 2 MnO4 minus plus 5 C2O4 2 minus, that gives you 2 Mn2 plus 8 H2O plus 10 CO2. So that is the balanced reaction. Okay. So I'll explain quickly how we can balance a redox reaction. So that is it. There is another method that we will be discussing it in unit 5, how we can balance them as well, right? So those are called as this is how we can balance a redox reaction. Okay. So the next video I'll talk about disproportionation reaction. It's a very small video on that, and then we'll move on to the next part as well. So if this is helpful, give us a thumbs up and consider subscribing. Thanks for watching.